Snell's law, the final frontier. Light, how it travels, how fast it travels, and its angle of trajectory. Hello, I'm a well-respected scientist in the Department of Science, and I'm here to prove Snell's law. Snell's law states that angle alpha over angle theta equals c over v, which proves the angular relation between point A and point B from a light ray.
Alright, so if we imagine letter A, C, B, and V as constant, then it's easy to imagine that this distance x from here to here is related to angle alpha right here. As x changes, alpha will change as well. And then, similarly here, the distance s minus x will be related to angle theta right here. If we imagine a rectangle here, it is easy to see that this angle here is equal to the one here, which is also theta, and that this angle is the same as this one.
By using the Pythagoras theorem, we can solve for c, which is the distance traveled above the water. And thus, we can do the same on the other side and solve for v, which is the distance traveled below the water. Then, by using trigonometry, we can solve for the angles alpha and beta. Note that t equals d over v. Therefore, in using this formula, we can find the time it takes to travel above and below the water and find the total time by adding them. And then find the derivative by using the chain rule, and then simplify. Although this looks complicated, if we look closely, we have worked out everything in the bubble before. Do you remember what it is?
Mr. K.
That's right, we solved it using trigonometry.
And to prove Snell's law, we set the derivative of time to 0 because light takes the fastest route.
Therefore, sine alpha over the velocity above the water is the same as sinus theta over the velocity under the water. Therefore, by rearranging this, we can solve v1 over v2 is the same as sine alpha over sine theta. And thus,
We have proved Snell's law!